extreme learning machine, which is application area, which is wind speed forecasting, and the key findings I found that is the improved prediction accuracy and computational efficiency. So here the limitation for that of that paper I found out the research gap, which would say the limited to forecasting applications. And there's more on the papers, research paper which I found. So there is in the year of 2024 genetic gray wolf optimizer which is used in the wind farm layout optimization, and the key findings are the improved equal energy production and convergence, and the research gap I find out that is a focus on layout optimization only, not on the better performance or better efficiency when the fluctuation of the environment or the wind energy experiences by the wind blade. So here are the research gap. From the literature review, it is found out that most of the existing research focuses on wind speed prediction, system optimization, energy system sizing, or wind farm layout optimization separately. But many studies use machine learning or optimization techniques individually. But very few combine these approaches for adaptive wind turbine control. So, in wind turbines operates under highly variable and uncertain environments where wind, speed, turbulence, and speed system dynamics changes continuously. Therefore, there is a need for an intelligent control framework that can learn from system behavior and automatically adjust control parameters. I'm just a gentle reminder that 8 minutes have already passed. Oh. So, 2 minutes are remaining and 5 for question and answer round. Okay. There is the objective. The main objective of this paper is to develop and evaluate machine learning assisting genetic algorithm based on a adaptive pitch control system for wind energy conversion system operating under variable wind conditions. So here I use that methodology for the closed loop architecture of the proposal. Also deeply honored to welcome our next session expert, respected Dr. Sachin Goyal sir, Associate Professor at IIT RGPV Bhopal. He has extensive experience in teaching, research and academic administration in computer science and information technology. He has published over 80 research papers in reputed national and international journals, holds 2 patents and focuses his research on emerging technologies and innovation. Please put your hands together. Before starting our presentations, I would like to remind you some rules for presentation. First, each presenter will be allotted a total of 15 minutes of time, in which 10 minutes is for presentation and 5 minutes is for Q&A session. This includes your core presentation time, followed by a brief Q&A session with our session chair. I request all presenters to strictly adhere to the timeline so we can maintain the smooth flow of the session. The judgment will be done on the basis of following parameters. First, rationale of studies. Second, literature review. Third, methodology. Fourth, presentation clarity and organization. And fifth, Q&A handling. Thank you and all the best to all the presenters. First, I would like to invite Kaushal Singh sir for real-time simulation-based performance evaluation of P&O, ACO and PSO MPPT algorithms for grid-integrated PV systems. Please put your hands together.
Good afternoon, one and all present here. My name is Kaushal Singh. I am pursuing my PhD in IIT RGP Bhopal in Electrical Engineering Department. Today's my topic is real-time simulation-based performance evaluation for P&O, ACO. P&O is part-up and observation, ACO and colony optimization, and PSO particle swarm optimization, MPPT algorithms for grid-integrated PV system. So these are the outlines which I will be covering in my presentation: abstract, introduction, literature review, research gap, objectives, methodology, results and discussion, and conclusion and future work. So next slide. So abstract. giving you about the brief what work we are doing. The objective we have covered in this presentation or in our research work was the comparative evaluation of the three MPPT algorithms that are P&O, ACO and PSO. These algorithms have been utilized for a 50 kilowatt power grid system which is connected with these MPPT algorithms. So the novelty of our work totally rely on the methodology what we have done. The methodology means the MPPT algorithms we have used in this system one by one. First, we have utilized the P&O algorithm and we have tracked whatever irradiance we are getting in the PV system, and then the ACO system and then the PSO system. These systems not only in the software simulation we have done, but also we have taken granted that in the literature only simulation part has been done. So what we have done that real-time simulation can be applied or not. So we have validated our results in the Bhopal RT simulation, which is a real-time software tool. So the evaluation metrics for the three algorithms for the comparison was tracking the speed, settling time and steady state stability. Also, since we have connected the grid part also, so we have calculated the grid power quality, that is the total harmonic distortion. So the key findings which we have got in our work, we have got that the intelligent optimization technique, that is the PSO and ACO, have clearly came forward with the conventional P&O compared to the P&O algorithms. And all the algorithms were strictly followed the grid capability of THD less than 5%, that is in the IEEE standards. Please next slide. So this is the introduction. As we know that for a grid system connected to the PV system, this is the most easiest and the technological benefit which presently we are using. However, we cannot deny that in the PV module that is highly non-linear. Non-linear means, as we know that if the irradiance is varying, irradiance means the solar radiation is varying, that we know it moves from 0 point to the highest point in the afternoon at 12 or 2 o'clock and then falls down again to 0 in evening time. So due to this irradiance problem, the MPPT algorithms, what they work, they try to extract the main power, that the maximum power they can track, that is called the MPPT. So the non-linearity is there, and how we can extract the maximum power from that is the main problem. So if we are not using the correct algorithm or we are not using the correct MPPT controller, then our wastage of energy will be approx exceeding beyond the 20 to 30%. So the in the industry, definitely, since P&O, conventional P&O algorithm is easiest to implement. Therefore, the industry is presently using P&O algorithm, but it is highly not efficient. So what the researchers are doing, they are using the intelligent optimization techniques, that is PSO and ACO. By that we are getting a better efficiency, but yes, the computational algorithm, that is the complexity of the algorithm, that also increases. The research that we have found here is that the only problem that lies here is the real-time validation. The real-time validation is not present in the existing literature. So what we have tried, that we are using this MPPT algorithm for the real-time validation. So we have divided our work in the objective like a unified comparative framework. So we can utilize we can compare the three algorithms in a identical manner, not as a P&O is using some different irradiance or ASO is using some different condition. We have utilized the same unified framework, identical framework for all the algorithms. And obviously we have done the result in the Bhopal RT, that is the real-time platform. So please next slide. So literature review, what I want to discuss in the literature review, that is the conventional MPPT. Already I have described that industries are using this P&O, conventional P&O method because of its simplicity, but it lacks because of the inefficiency and the steady state, persistent steady state oscillation that is covered in the literature. Then the researchers have again started to optimize the things in a meta-heuristic way or in an intelligent optimization techniques, that is the PSO and SEO, where we are excelling in the global maximum power point tracking problems. But yes, the complexity of the computation is also increased. Real-time validation is not at all done. So we have utilized this as a research gap, and we will be using it in the we are using it in our work. So next slide. So these are the objectives which we are be working on in this work. Unified comparative framework that already have done, that identical work for all the MPPT algorithms has to be done. Realistic dynamic profiling. Realistic dynamic profiling. So what we have done is we have done a clear irradiance, that is the starting to the end. The variation of the irradiance which we have utilized is the realistic of the solar power. Then the third is the comprehensive grid assessment. Comprehensive grid assessment means, since we are connected the grid part, that is 50 kilowatt grid part, so whenever we connect any two systems, so synchronization is the must part. So for synchronizing that thing, we have calculated the THD part. So all the algorithms what they have gave, we will see in the result part. And the last and the most important part is the real-time hardware simulation. So what we have validated is already done in the real-time work. So that can be implemented in the hardware part also. So next slide. So this is the system configuration. This is the model which we have used. You can see in the right side, there we have used the PV array, that is the power stage portion, where we have used the 50 kilowatt system, and it is connected to the grid via a DC-DC boost converter. What the DC-DC boost converter does, it just increase the voltage which we are getting from the PV array, and it will increase the level till up to the grid voltage so that we can synchronize it. And there we are using three-phase voltage source in converter. The voltage source converter is used to convert, or we can say it is holding both the synchronization problem. This synchronization is done through the PLL, and the algorithm for that we have used is the synchronous reference frame, that is DQ control method. So the MPPT algorithm implementation, PSO, P&O we have done. It is a classical conventional MPPT algorithm, and we have taken the fixed step size of 0.01. ACO, as we all know, is a bio-inspired probabilistic search. We have taken the 10 candidates as ends and pheromone updates, and PSO solve.
Sorry for interruption. 8 minutes has been passed. Only 2 minutes left.
So PSO, it is a 10 particles we have taken, and the updation is done on the basis of the velocity and position tracking. So next. So results, what I want to discuss about the, here we can see that the real-time grid synchronization and current tracking. All the three, we can see that all the three results for P&O, ACO and PSO, they have been tracked as the irradiance is present. Same sinusoidal waveforms we can see here, but the only difference we are getting is the, if you will see in the extreme right side PSO results, there is a clean sinusoidal waveform. Here what in the P&O and ACO, there are slightly ripples in their tracking speed. So the tracking speed of P&O is slightly less and more in the ACO, but PSO has a clearer and clean sinusoidal waveform. So that gives us the representation that the synchronization done in the part is correctly working with the unity power factor and superior modulation in the PSO part. Next slide. This is the core MPPT performance. This is the main slide which I wanted to tell you. PV power that is expected and the DC link stability. The DC link stability, that is DC voltage 800 volt, we have maintained in all the three algorithms. But yes, the PV power that is fluctuated in the P&O and ACO, which is not at all present in the PSO part. So that makes this PSO more suitable algorithm by the other two, since zero steady state oscillations are there in the PSO part. So next. So when we will compare the grid side calculation, we have seen for a 50 kilowatt active power injection, the total harmonic distortion for perturb and observe is 2.9%, that is the lowest. ACO we are getting 3.9%, PSO we are getting 3.4%. The higher total harmonic distortion is just because due to the continuously variation of the duty cycle in the ACO and PSO part. Okay, overall I would like to say that PSO is the most suitable and comfortable algorithm for the dynamic variation in the solar radiations. And conclude that PSO is much more better than the other two algorithms which we have used. In future, we are using that the how we can experimentally verify. Already we are doing real-time validation, but how we can start the experimental or hardware work there. And if we can use an hybrid algorithms, here we have used an individual algorithms of P&O, but if we will use an hybrid algorithm, that will be much more better and will give us much better results, and the complexity will also be reduced. Thank you. Yes, sir.
क्या टॉपिक आपका था?
Real time simulation based.
Simulation of PNO is so PSO. What great integrated tool system. यहाँ पे PSO पर काम किया है सर ना?
Yes, sir. Participants.
Issue जनरली अगर लोकल मिनिमा का एक इशू आता है.
Yes, sir.
तो PSO के माध्यम से PSO हमने लिया भी है. क्या होता है लोकल मिनिमा क्या होता है?
सर लोकल मिनिमा एंड लोकल एक्चुअली
आपके में आया ये क्या इशू आया नहीं आया?
नहीं सर, मेरे में तो ये इशू नहीं आया था, बट यस ये इशू होता है एक्चुअली में जो PSO बेस्ड एल्गोरिथम्स है दैट वर्क्स ऑन द ग्लोबल बेस्ट पार्ट, एंड ग्लोबल बेस्ट लाने के लिए जो हमने स्वार्म यूज किया हुआ है, जैसे मैंने 10 कैंडिडेट स्वार्म यूज किए, 10 स्वार्म यूज किए, 10 पार्टिकल्स यूज किए, ऐसे ही हम लोग और भी स्वार्म यूज कर सकते हैं. सो वो अपने इंडिविजुअल बेस्ट की तरफ जाते हैं, साथ में जो ग्लोबल बेस्ट होता है उसकी तरफ जाते हैं. तो जब वो दोनों चीज को ट्रैक करते हैं तो वो लोकल जो मिनिमा रहता है उसको फॉलो करने में थोड़ा सा कंप्यूटेशन में प्रॉब्लम जाती है, वो कॉम्प्लेक्सिटी आती है. तो ये सर वो है लोकल मिनिमा प्रॉब्लम है.
ये आपने एक्सपेरिमेंटली कराया है कि आपने एक्सपेरिमेंटली और सिमुलेशन ओनली सिमुलेशन?
सर सिमुलेशन मैंने मैटलैब पे किया है, देन इसको रियल टाइम वैलिडेट करने के लिए मैंने ओपनआरटी प्लेटफॉर्म का यूज किया है. तो ओपनआरटी प्लेटफॉर्म इज फॉर रियल टाइम वैलिडेशन. अब एक्सपेरिमेंटली है सर, उसको आगे एक्सपेरिमेंटल फॉर्म में लेने के लिए फ्यूचर
वर्क यू हैव डन ओनली द
सिमुलेशन एंड रियल टाइम वैलिडेशन की ये रियल में वर्क करेगा. नाउ आई विल ट्राई टू वर्किंग द हार्डवेयर पार्ट. जो रियल टाइम सिमुलेटर है ओपनआरटी, उस पे ये वर्क करो, उसी के रिजल्ट्स थे.
बेस पेपर कौन सा है आपका? पेपर इज लाइक ए बेस पेपर.
सब बेस पेपर एक
कंपेयर करा है इस पेपर से अपने रिजल्ट्स?
सब बेस पेपर में सिर्फ एक ही एल्गोरिथम का यूज किया था, तो मैंने उसको कंपेयर किया है. तो उसमें बेसिकली सिर्फ P&O का एक वर्क था. तो मैंने क्या किया है कि इसमें अलग अलग जो एल्गोरिथम्स हो सकती है जिससे हमें बेटर एफिशिएंसी मिल सके और बेटर रिजल्ट्स मिल सके, उस पे वर्क करने की कोशिश की. तो जो एल्गोरिथम्स मैंने यूज किए उसमें मुझे समझ में आया कि अगर हम PSO का यूज करेंगे तो बेटर हमें रिजल्ट्स मिल सकते हैं.
Anybody else?
So you are from which college?
IETR. Thank you, sir.
Thank you so much. Next, I would like to invite Rashmi Sachit ma'am to present machine learning enabled design of frequency reconfigurable split ring antenna for sub-6 GHz application. Participants, please strictly adhere to the timeline. 10 minutes are for presentation and 5 minutes are for Q&A session. Please put your hands together.
Thank you so much. Good afternoon, respected teachers, professors, and all other participants over here. I am Rashmi Satintikar, presenting my paper that is 2034. Paper ID 2034. That is machine learning enabled design of frequency reconfigurable split ring antenna for sub 6 gigahertz application over there. And here I am presenting with my Vandana Vikas Thakre guide and Priyanka Garg ma'am as a co-guide. And I am from MITS Gwalior. So please next. So here these are the outlines which my presentation will follow these outlines. So please next. So here the abstract, actually I have designed simulated a split ring antenna about for sub 6 gigahertz application, and here I have optimized it by using machine learning techniques. Here I have used 7 machine learning techniques, and those are first one is linear regression, second one is lasso, then KNN, then random forest, then XGBoost, and then SVR and MLP. These regression techniques I have used, and I have checked the parameters by using R-square score, MSE, MAE, and RMSE parameters. And now after that the random forest works very better, by which is given over here, that is R-square score achieved 94.5%, and the error was very less. And the particular split ring antenna, which is the design which is very optimized and work for 3 states of its. I have used 2 diodes for this, and it works on to 3 operating frequencies, that is 3.3 gigahertz, which is used for 5G and 78 applications. Second one is 4 gigahertz, which is used for C-band, and third one is 5.1 gigahertz, which is used for 5 gigahertz Wi-Fi band. Okay, so 3 frequencies I have got here, and the gain obtained is varied between 3.02 dBi and to 5.70 dBi. And here the proposed design provides compact, efficient, and computationality faster solution for the modern 5G, WLAN, Wi-Fi, and IoT applications. So please next. Now here the introduction. The conventional antennas is what? The fixed particular antenna which is used for a single frequency band or single frequency. But here I am designing the reconfigurable antenna, which the single antenna can be used for the multiple frequencies or can multiple bands over there. So here the reconfigurable antennas are of 4 types. I have worked onto the frequency reconfigurable antenna. Frequency reconfigurable antenna means the antenna will be used for the single antenna structure will be used for multiple frequencies. So I have used machine learning over here to optimize the simulation, because conventional process takes lots of time to process, as well as the working with simulations, working with the process means every time we have to change the dimensions and simulate each thing. So it will take many more days for that case, and machine learning gives the data result in very few minutes, so it is cost effective. So please next. Literature review. From these literature reviews, it is noted that most of the work is done with the they can work with the pattern as well as the frequency configurable antenna, but the design is complicated. Here I have designed a simple split ring antenna, but as well as it works for to the 3 frequency bands. The single antenna can be used for the 3 frequency bands. So please next, sir. Here the research gap from these, that is repeated full wave electromagnetic simulations increases computational cost as well as antenna design time. The second one is the simple geometry, the complex antenna geometries and switching structures increases design and implementation complexity. But here the simple design will works effectively. The third one is because of we are using machine learning, so it is machine learning assisted frameworks which for rapid antenna performance, so that it will gives output very fast, and so that it needed the accurate antenna performance perception prediction. So particular which type of algorithm will be gives proper output for particular design, that will be verified. So please next. Next, please. Sorry. So, methodology. Here I have used this type of methodology. First of all, I have designed a reconfigurable antenna by using CST Studio Suite, and then performance, then apply the parametric sweep. The parametric sweep is applied for the outer ring as well as for the inner ring. The 6 points I have used for each rings, so that total data will be 36, and so that for 451 frequency steps I have got 26,260 36 data will be there, and on that I got data process. Then I did data processing for that. For applying machine learning, I have just separated that for 80% data and 20% data. 80% data used for training and 20% for the testing, and then validation will be applied. Then here the analyze the performance of ML model. The 7 models I have analyzed by using the performance evaluation. 4 evaluation models will be used, 4 evaluation parameters used for that case, and then they obtain the dimension. After that, which the algorithm which works properly, more accurate, according to that particular model, I have just obtained the particular dimension, which is the correct dimension for getting a particular frequency which I have required, or with more S11 value, means more negative S11 value. And according to that, I have designed that antenna, and then simulate the antenna again by using CST, and then analyze the result. So please next. Here the result of discussion, just I have said that I have designed the ring antenna. Here the single ring which is used, the inner radius and outer radius I have changed. The inner radius diameters I have step size I have taken as 6, and 6 points I have taken for the outer radius also. So I have first of all checked the simple ring, then I have cut it. Means after getting the proper dimension after the algorithm use, then only I have cut the particular ring and apply the diode for that. Here the diode means the pin diode I use, which is used for the reconfiguration. Means the 2 diodes, means there should be the 2 raised to the power 2, that means the 4 combination should be there. Now because the frequency here, the length of the whether if this diode is on, the particular electrical frequency, electrical length will be same, and if this on, so electrical length will be same. So at least those, when both diodes will be on,
Only 2 minutes.
only 2 minutes. Okay, thank you. Only when both diodes will be on, then I have got please next. I have got the frequency as both on, then I have got the frequency as 4 gigahertz, and when both the diodes are off, then I got the frequency as 5.1 gigahertz, and when one is off and another is on, I have got 3.3 gigahertz frequency. So it works, it utilizes the 3 states of the frequency, and here the prediction and CST simulated, where it matches both curves matches with each other. So predicted and measured both will be similar to each other. Here I have got the frequency graph for the on off on conditions, and the gain I have obtained for frequency plot, that is between, which varies between 2.02 to 5.07 dBi. So please next. Here the conclusion: successfully designed a frequency reconfigurable split ring antenna for enabling numerous resonant frequencies, that is these frequencies I have already told. Then the proposed antenna achieved frequency reconfiguration for satisfying S11 characteristics using pin diodes with the maximum of the steps, maximum of the stages. Then here the random forest model will use algorithms will best prediction performance, which provide best prediction performance with R-square score as 94.5% and MSE as 0.963 and ME as 0.373 and RMSE as 0.995. So due to simple shape and flexible frequency configurability, The suggested antenna can be used for 5 gigahertz 5G sub 6 gigahertz application Wi-Fi band, as well as can be used for IoT applications too. So here the future work, here I have done the simulation work. Now the fabrication work will be, I am processing on that. Yes, thank you. So here the my presentation is more. Thank you.
और जो बच्चों अपने यूज किया है मशीन लर्निंग
Yes sir.
किस बच्चों ने यूज किया है
Yes.
मशीन लर्निंग बच्चों ने कौन सी लिया है
किसमें यूज की, कौन सी यूज की है?
हाँ
So linear regression, lasso, XGBoost, then random forest, and then SVR, and ML. These 7 algorithms I have used.
आप लोग अब इम्प्लीमेंट किया
Yes sir.
सबसे बेटर किसका लगा
So random forest perform very better.
जो रैंडम फॉरेस्ट आपने ट्रेन किया था कैसे किस माने में
Sir, actually, it will provide more with more accurate accuracy. That is 95.
फायदे होते हैं रैंडम फॉरेस्ट के apart from other machine learning
Sir, actually, it is not linear. Linear means if the input changes, the output will be changes. So random forest, it is of.
This is based on random forest मतलब क्या है किस अप्रोच पे वर्क करता है
So random forest means it works on to the supervised learning.
कैसे ट्रेन करती है
So yes sir. First of all, I have got the datas. Then I have cleaned out that datas. I have taken as inputs and input articles and output means dependent and independent variables I have there. Independent choose as S11. And then after that I have provided it to the machine learning, means apply the Python on that, and then I got the result, and then the more accuracy I have got here with the random forest for this particular design.
किस पैरामीटर्स काम किया
So parameters R square score, RMSE, MAE and MSE.
RMSE फंक्शन
किसका सर?
RMSE
RMSE random sorry sir, mean square error. Sorry, random mean square error.
कैसे निकालते हो
Yes sir.
कैसे निकाला
Sir, mean square error means it is of average of square root of.
निकालते क्यों भाई you conclude RMSE अपने परफॉर्मेंस पैरामीटर्स हम RMSE निकालते क्या क्यों निकालते हैं भाई केस क्या है
सर एरर देखते हैं एक्चुअल एंड प्रेडिक्शन जो वैल्यूज है उसके बीच में क्या एरर है. सो अगर एरर ज्यादा है मतलब प्रेडिक्शन सही नहीं है. अगर एरर कम है 0 point something means the prediction is good, means accuracy is good over there.
accuracy निकाली रहे एरर भी निकालते हैं अपन
हाँ.
और क्या निकालते हो कौन सा पैरामीटर लिया आपने
RMSE ये एरर के हो गए और सर R square स्कोर भी निकाला है.
ये क्या होता है
So R square score means that is of how the actual is perfectly matched with the prediction output of machine learning. Means whatever I got the dimension from the algorithm, तो उसको हम फिर से अप्लाई करते हैं CST में और देखते हैं आउटपुट सही आ रहा है क्या as it is.
ये आपने हार्डवेयर डिजाइन करा है कि सॉफ्टवेयर?
नहीं, this work is of simulated. Now I am working on that hardware.
Why not use the hardware? Because आपका जो एरिया है वो क्या है इलेक्ट्रॉनिक से रिलेटेड है.
Yes.
उसमें because hardware design is more efficient.
Sir, yes, I am working on that. Till that.
क्योंकि सॉफ्टवेयर इफ वी डिजाइन द सॉफ्टवेयर अगर आपने इसको सिमुलेट करा सॉफ्टवेयर सो जितनी भी एल्गोरिथम यूज करिए यू हैव यूज द 7 एल्गोरिथम.
Yes.
Then when you implement it, मैंने आपने खुद ने डिजाइन नहीं करी ऑलरेडी ये implemented एल्गोरिथम है.
Sir, इलेक्ट्रॉनिक स्टूडेंट तो फिर हम.
तो उसमें आपकी नोवेल्टी क्या है? आपने डेटा कहाँ से लिया? वैल्यू कलेक्ट.
Sir, novelty is in antenna. My novelty is in antenna. We have. हाँ?
और आपने डिजाइन ही नहीं करा हुआ implement.
नहीं सर, एंटेना तो मैंने ही डिजाइन किया है CST में.
सॉफ्टवेयर में.
Yes sir, simulated. I have simulated that antenna and obtained the S11. So my main work is antenna designing, through which I got the particular frequency, means the single antenna used for multiple frequency bands. single antenna used for multiple frequencies. That was the main work.
Your
The
design
machine
is
learning used for optimization.
okay. You collect data from somewhere websites. No? So your design is extended for the 5G or 6G also?
Sir, till that 6 gigahertz, means sub 6 gigahertz. Sub 6 gigahertz.
6G को भी support कर लेगा आपका.
Sir, mostly. हाँ.
टेस्टिंग हो गई?
नहीं सर, अभी फैब्रिकेशन नहीं हुआ है. It is simulated work. It is simulated
My
work.
suggestion is firstly convert your work in जो डिजाइन है उसको firstly आप करना उसको हार्डवेयर पे शिफ्ट कर दो.
Yes, sir. Yes, sir. The process is going on, sir. Actually, it is
अगर
under.
आपका विषय ऐसा है कि हार्डवेयर विषय
तो ये जो टॉपिक है ना हार्डवेयर करो.
But first of all, I have to use the simulation क्योंकि डेटा पूरा हमारा क्रिएटेड है. क्योंकि अंडरनेट डिजाइन तो खुद ही क्रिएट कर रहे हैं ना. इसीलिए. Thank you, sir. Thank you, sir.
Thank you so much. Up next, we have Atul Sharma sir presenting machine learning based surrogate estimation of S11 for a dual band retina in a RF energy harvesting system for IoT enabled application. Put your hands together for sir.
Good evening to all respective faculty members and dignitaries. My name is Atul Sharma. I am a PhD student in the Department of Electronics and Communication at MIT's DU. And today I am here to presentation of my research work titled is Machine Learning Based Surrogate Estimate of S11 for a Dual Band Retina in an RF Energy Harvesting System for IoT enabled applications. In this work is carried out under the supervision of Dr. Vandana Vikas Tarpe and my co-supervisor is Dr. P.K. Singhal sir. These are my outlines, which I will discuss in my further slides. Firstly, I discuss about background of RF energy harvesting system, and after that, I will discuss about literature review, research gap, objective of my research work, and methodology, results, and discussion. After that, I will conclude of my research and future work. Next. So these are my abstract. I have designed a dual band retina for RF energy harvesting system with the help of CST simulation retina for RF energy harvesting at operating frequencies 2.49 GHz and 4.9 GHz also. Here we use a machine learning models for optimization of antenna to predict S11 of antenna, and here I designed a rectifier for convert RF energy to DC power for IoT applications. And here we use three machine learning models: linear regression, random forest, and KNN for prediction of antennas as well. And we saw our prediction is much better than CST simulation because we achieved minus 40 dB return loss of antenna, and we achieved 80% efficiency of retina. So we achieved 1.8 volt of this retina for IoT applications. This is our introduction of retina. We know that very well now. That time IoT devices very rapidly increases. So some IoT devices work on batteries. So RF energy harvesting is a possible source of reduce RF batteries. And we know that first of all we discuss about what is RF energy harvesting. RF energy harvesting is a system that capture RF energy from ambient environment with the help of antenna, and after that we use an impedance matching circuit for between antenna and rectifier for impedance matching. And rectifier is the most important component for convert RF to DC. And here multiple type of topologies use rectifier like voltage development multiplier, texture charge pump, and here we use full wave rectifier and pi matching circuit use. And here we use microstrip patch antenna, because microstrip patch antenna is a very largely used in communication devices like mobile communications and Wi-Fi. So we use a microstrip patch antenna, and we predict S11 parameter, because S11 my work is focused on capture more power from ambient environment. After this, we convert maximum power RF power from for DC convert for DC power. So that's why we our main focus is S11, because our antenna is more achieve return losses like -20, -30, above 40. So it is a good for our, because when our antennas capture more power from ambient environment, then we pass through the for rectifier power rectifier for converter to DC supply. So next slide. This is my literature review. Here some literature reviews that some literatures are reveal that they work on only rectifier. They work only rectifier for maximum efficiency, and some literatures are revealed that they use optimization machine learning only antennas. They were not work on antennas and rectifier, and we are work on both of. We work antenna, we design antenna, we optimize to machine learning, and after this we design a rectifier. So it's a complete system of RF energy harvesting. So next slide. This is our research gap. We found some retinas are not working on 2.4 and 4.9 gigahertz, and they not achieve 80% efficiency with the with combined system, and they are not and they not achieve the maximum return loss with optimization of RF and machine learning. So my work is totally dependent on the maximum power efficiency convert for RF energy for IoT applications devices. So it's the next slide. My four objective is, first is maximum power achieved for V output, voltage output, and we want more antenna efficient, like return loss, like 4 -40. Just you can see my antennas achieve return losses of -40, and we found and we want to reduce time consumption, because when we simulate antenna through CST, when we using optimization technique through CST, it's very time taking process. So here we use machine learning models to reduce time consumptions and provide a more accurate and more effective results of antenna. Again, sorry. Yes, next slide. So these are my methodology. Here we design first of all antenna in CST. After this, we perform a parametric sweep for generated data sets samples. Here we generate 3,600 samples and data sets for machine learning models, and after that we use data processing, and we split data 80% for training and 20% for testing. After this, we applied 3 machine learning models like linear regression, KNN, and random forest, and we evaluate performance on 3 parameters: R square, RMSE, and MSE.
Sir, 8 minutes, 2 minutes.
Okay, ma'am. After this, we evaluate best model and we evaluate we found random forest model is more accurate compared to other models because random forest achieve 95% accuracy because R square is 90% accurate. After this, I have designed a rectifier through ADS and we use a pi matching circuit and HMS 2850 Schottky diode and full wave rectifier. After this, we validate this system through. After this, we measure antenna through a spectrum analyzer and we validate the system with the help of DSO. So, okay. This is my design. Here we use a microstrip patch antenna designed with techniques of DGS, defected ground system, and here we optimize for two parameters, parameter A and B, and after this, here we can see these are my impedance matching circuit, and these are my full wave rectifiers. And we know that here we can see our result. My directivity of antenna 5.3 and gain and gain 2.90 dBi and 6 at 4.9 dBi directivity and 4.8 gain. It is a quite impressive results for antenna and it is a simulated results and
Sit times.
you can see
अगर आप IoT यूज नहीं करोगे तो not use the IoT. Any impact your result?
सर मेरा जो मेन टारगेट है एक्चुअली मैं सर इसके पहले काफी रेक्टिनस बना चुका हूँ विद सिमुलेशंस टू फैब्रिकेट मैं एंटीना एरे का यूज करके और डिफरेंट टाइप के रेक्टिनास बना चुका हूँ जिसका मेरा मेन टारगेट जो है सर कि हमें मोर इफेक्टिव मोर आउटपुट चाहिए अभी तक मैंने सिमुलेशन पे 2 वोल्टेज अचीव किया है और मैंने उनको टेस्ट भी किया तो वो मेरा सर 1 पॉइंट सर IoT इसलिए लिया है क्योंकि सर कुछ IoT एप्लीकेशन
आपके वर्क में IoT का यूज क्या है
सर IoT इज एप्लीकेशन पार्ट
एप्लीकेशन में क्या करना है IoT से
सर वायरलेस सेंसर्स जो हमारे पास होते हैं इनपुट है और सर LEDs हो गई हैं तो उनको सर हमें ब्लिंक कराने के लिए उनको पावर चाहिए तो सर हमारा जो रेटिना है वो 1.8 वोल्ट जनरेट कर रहा है
प्रॉपर IoT का यूज है IoT होता क्या व्हाट इज
सर IoT
है क्या मतलब
इंटरनेट ऑफ थिंग्स जो सर ऐसे सेंसर्स या ऐसे डिवाइसेस जो
तुम डेटा कलेक्ट कर रहे हो क्या
नहीं सर डेटा हमने सर एक्चुअली CST सिमुलेशन से जनरेट किया है पैरामीट्रिक स्विच जनरेट लगा के वहां से हमने उसका
डेटा वहां से लिया है तो फिर IoT
सर IoT इज एप्लीकेशन पार्ट है
एप्लीकेशन मतलब समझ में नहीं आया एप्लीकेशन IoT क्या होता है वो डेटा जनरेट करता है IoT जो होते हैं IT डिवाइसेस होती हैं इज ओनली यूज्ड फॉर द जनरेट योर डेटा
ओके सर अगर वो
डेटा तुम कहां से ले रहे हो
सर वो IoT जो डिवाइसेस हैं उनको अगर हमें काम करने के लिए सर कुछ पावर देनी होती है तो हमारा जो RF एनर्जी हार्वेस्टिंग सिस्टम है वो उनको
IoT मतलब क्या होता है IoT मतलब अपन कहीं भी किसी भी ऑब्जेक्ट पे अगर हम चिप लगा देंगे तो वो डेटा जनरेट शुरू कर देता है
सर जैसे RFID टैग सर जैसे RFID टैग है वो भी एक RF एनर्जी हार्वेस्टिंग सिस्टम का एक एप्लीकेशन पार्ट है बिकॉज़ उसमें भी सर हम RF एनर्जीज जो है एम्बेडेड एनवायरनमेंट में उसको कैप्चर कर रहे हैं वो कन्वर्ट कर रहा है यूजेबल DC वोल्टेज में सर आफ्टर
तो समझ में आपके एप्लीकेशन में IoT का क्या एप्लीकेशन है
सर IoT इट्स एप्लीकेशन पार्ट है बिकॉज़ हम जो हमारा आउटपुट आ रहा है वो एप्लीकेशन IoT डिवाइसेस जो एप्लीकेशन डिवाइसेस है उनको पावर देने के लिए सर हमने कुछ है
जैसे इनका भी था आपको तो इंजीनियरिंग का ना आपने तो बिना IoT के
IoT is a real time रियल टाइम एप्लीकेशन के लिए आफ्टर वो एंटीना बनाने के बाद वो रियल टाइम एप्लीकेशन के लिए यूज करेगा
डेटा अगर स्ट्रीम जनरेट कर रहे हैं तो IoT जनरली यूज होता है फॉर द डेटा डेटा ट्रांसलेट और डेटा ऑलरेडी आप इंटरनेट से ले रहे हो।
नहीं सर, डेटा हमारा जनरेट CST से हो रहा है सर, CST में हम सिमुलेट कर रहे हैं और वहां से सिमुलेशन से हम उसका डेटा को पैरामीट्रिक्स में लगा के डेटा कलेक्ट कर रहे हैं और वो डेटा हम यूज कर रहे हैं सर मशीन लर्निंग मॉडल्स को ट्रेन कराने के लिए। हम उस डेटा से मशीन लर्निंग मॉडल्स को ट्रेन करा रहे हैं, उनको एक पैटर्न समझा रहे हैं जिससे क्या सर कि हमारा जो सिमुलेशन टाइम हमारा CST में ज्यादा लगता है उसको हम कम करके
टाइम को नोटिस करने के लिए हमारा जितना टाइम जा रहा है उतना टाइम कम जाएगा मशीन लर्निंग से डायरेक्टली हमें डायमेंशन मिल जाएंगे एंटीना
और सर उसको हमने वेरीफाई भी किया है कि हमने CST में उसमें सिमुलेट करा के दोबारा से जो कि एक अच्छे रिजल्ट्स प्रोवाइड किए हैं। ठीक, थैंक यू सर, थैंक यू सो मच।
Thank you so much. Now we have Sanjeevni Joshi ma'am presenting a meta-heuristic tuning approach SMO optimized ResNet 18 for enhanced pneumonia detection. Please put your hands together for
Good afternoon all. I'm Sanjeevni Joshi from the Department of Mathematics, Bioinformatics, Computer Application from IIT Bhopal. I'm here to present my work on SMO optimized ResNet 18 for pneumonia detection from a chest X-ray. This work was co-authored by Ghanshyam Singh Thakur, which is also my PhD supervisor. So next. So these are the outlines which I'll be presenting in my presentation.
Ma'am, please topic
SMO optimized ResNet 18 for pneumonia detection from chest X-ray.
मैम आपने जैसे जिसमें लिखा है मेटा ह्यूरिस्टिक ट्यूनिंग अप्रोच
That's
इसका टाइटल सर्टिफिकेट टाइटल आता है ना इसलिए पूछ रहा हूं।
yes sir.
कौन सा टाइटल फाइल में
ये हम लोगों ने सर्टिफिकेट में ये लिखा है मेटा ह्यूरिस्टिक ट्यूनिंग
Yeah, I will go with it, ma'am. That is fine. This is just a topic of presentation. Yeah. I've shortened it because length was ज़्यादा कम थी इसलिए. Next one. So these are the outlines I'll be presenting. Next one. So basically, in shorter form, the spider monkey optimization is nothing but an optimization technique which I have applied over in CNN backbone in order to hyper parameter tuning. So the idea behind this is just like if we have a machine, वो तभी अच्छे से काम कर पाती है जब भी ट्यून इट या उसको हम अच्छे से कॉन्फ़िगर करते हैं. सो बेसिकली यहाँ पर स्पाइडर मंकी ऑप्टिमाइजेशन वो बेस्ट कॉन्फ़िगरेशन CNN को करवाएगा ताकि हमें जो भी क्लासिफायर हम लगाएंगे वो क्लासिफायर हमें प्रॉपर या आउट परफॉर्म रिजल्ट दे. So basically my abstract is a shorter version which states I have applied an SMO optimized model over ResNet 18 so that like ResNet 18 hyperparameters were been automated by spider monkey optimization. So an introduction, I've chosen the disease pneumonia. So pneumonia is a common and potentially serious lung infection which needs timely intervention so that if we get the diagnosis on the time, if we get the diagnosis on time, we'll get the treatment on time. So chest X-ray is a primary screening tool which a doctor uses, a radiologist uses in order to consult that particular patient has pneumonia or not. So just this radiologist suggestion, the doctor visit, these things takes lot of time. So these time consumption, these things can be overcome by automating these things. So these automation have automatically these gap can be overcome by applying in computational techniques over these tiresome tasks. So CNN किसी भी images पे जब भी अपन CNN लगाते हैं तो it takes in visual patterns from it and it identifies the particular image on basis of that visual patterns only. So if chest X-ray अगर CNN के पास में हम पास करते हैं तो उससे कुछ visual patterns वो understand करते हैं, जैसे lung opacity है या किसी भी तरीके का abnormal region अगर chest X-ray में है तो वो उसी को observe करने के बाद में वो classify करेगा कि particular chest X-ray belongs to pneumonia class or normal class. Next. So this is the literature review. The first paper was my base paper. This was considered as a base paper because that paper was simply using a DenseNet as a classifier. So my work is basically divided into two different parts. First one is optimization, second one is classification. So I have two different base papers for the same. So first Rajpur, they have proposed a DenseNet based model. जहाँ से उनको accuracy have gotten good. So this is my base paper, and these 6 papers are totally based on the combination of classifier and different optimization techniques applied over it. Next. So these are also some optimization techniques which been addressed till today, but their application on medical images it's still been underexplored. So spider monkey optimization is the least explored algorithm till today. That's why I've chosen spider monkey optimization over other optimization techniques. Next. So the research that I've identified through the literatures are, the first one is the CNN needs to understand to which hyperparameter it should be working on in order to get a good result. So these hyperparameter tuning need to be automated. So addressing these things been less explored till today. So this is the first research gap I've identified. The second one, the SMO based tuning of a pneumonia chest X-ray. It's been less studied till today. So that's what I've covered in the previous slide. So I've chosen spider monkey optimization for the study because spider monkey optimization has never been applied over medical images for study. And the last one, instead of focusing solely on accuracy, I've also considered the different attributes like recall, precision, F1 score. These also been taken into consideration while talking about the model's performance. Next. So my objective is basically designing a classification model which will binary classifies a particular medical image as in pneumonia or chest X-ray, and same CNN based classifier needs to be get automatically hyper-tuned by using spider monkey optimization. And third one, by considering all the evaluation parameters like accuracy, recall, precision, sensitivity, specificity, all these considerations will automatically give model its generalization. And the key contribution is like I've used SMM based tuning framework for the classification, and clinically weighted function being used solely focusing on accuracy. Instead of solely focusing on accuracy, I focused on different parameters also. And the independent testing data been used in order to cross-verify whether the model been actually working on unseen images or not. Next. So the methodology firstly consists of data set. I've used a data set from a public repository Kaggle. The data set is of 5856 images, and the testing images consist of 624. I've applied a pre-processing over it, resizing it to the 224 by 224 because ResNet 18 only accepts the size of 224 by 224, normalizing pixel intensity so that model will understand its input data. And after I've applied an augmentation in order to provide data-centered generalization. Next. The model backbone I have chosen ResNet 18 over other models because ResNet 18 have outperformed comparison with the ResNet 50, DenseNet 121, MobileNet V2. So that's why I've chosen ResNet 18. I've also compared the different classifiers too. So pre-trained ResNet 80 being used as a feature extractor. The fitness function generated bin this 0.35 RM plus 0.35 RP, where they have balanced all the records. Next, sir. So this is an architecture first input data pre-processed and then spider monkey optimization been applied. and the spider monkey optimization candidates will be fed to the ResNet 18 classifier. It will calculate the fitness function, and this fitness will again remains in the loop till that time जब तक पूरा iteration का जो भी number of iterations है वो maximum reach out नहीं करते. And further the testing evaluation part. Next. So this is the convergence plot of both. The loss is degrading over the approaches, and the accuracy is gradually training and validation accuracy has been too much lesser over the different approach. Next. So this is the comparison, like confusion matrix that I have got, and the comparison with the baseline model. Next. This is the best configuration got, independent test performance values. Next. And this is the comparison with the different optimization techniques over the same classifier. So here, like over the 5-fold stratified, the SMO have outperformed all other optimization techniques with the same classifiers. Next. So I conclude topic over here that I've compared the SMO with other optimization, but the SMO based hyperparameter tuning have already outperformed all other optimization when applied over ResNet 18 classifier for the classification of pneumonia from the chest X-ray. So it have also considered the negative feedback as in gap penalty, so it makes it a generalized model. Next one. So these are the references. So previously particles one, volus optimization, and colony optimization, mother optimization. So other meta-heuristic optimizations. No sir, fine, proper Kaggle based.
So data Kaggle से.
हाँ sir. So I've taken it from Kaggle और दूसरा जो data लिया for a larger purpose RSNA challenge data से जो.
Indian based data or foreign based data?
Sir foreign based data. Chinese based.
So child जो बच्चे होंगे जो test कर लिया वो foreign data होगा.
So actually दो data set मैंने evaluate करे हैं जो बहुत smaller size में है जैसे 5856 है 7826 वाला. First one अभी जो use किया है that is from China. The second one that I've used वो जो है वो USA का है. And the RSNA challenge data is diversified data जिसको actually जिसका simulation 2 दिन से running हो रहा है.
वो term and conditions अलग हो जाती है ना अगर कोई
environment अलग है, वहाँ कुछ अलग तरीका, यहाँ कुछ अलग तरीका
तो
होगा.
अगर अपन डेटा यहाँ का लें तो ज़्यादा useful होगा ये research.
हाँ सर यहाँ का data है but it needs to be structured properly.
Globally
And the thing is like Indian Medical Council इतनी जल्दी वो चीज को disclose नहीं करता. There is a restriction of confidentiality, the restriction on sharing of a data. So that's why Kaggle पे कोई भी Indian based data set है नहीं pneumonia.
Thank you so much. Up next, we have Bharti Saxena ma'am presenting fairness-aware multitask learning for age gender prediction with demographic parity constraint. Please put your hands together.
Good afternoon, everybody. My name is Bharti Saxena, research scholar from ICETICS College Bhopal. I am presenting my research work on fairness-aware multitask learning for age and gender prediction with demographic parity constraint under the guidance of Ms. Rupali Chauran and Dr. Ritu Srivastav. These are my outlines of the paper. Sir, ICETICS College. Research scholar, MTech student. So the objective of my paper is to predict age and gender with a multitask learning model rather than a single task learning model. I have proposed two models, DB-Fair hybrid MTL and EQHN hybrid net for simultaneously age and gender prediction from facial images. My model combines CNN with attention mechanism to extract both global facial features and facial features which are effectively used for a purpose of extracting age and gender. I have addressed the limitation of previous model, which gives a good accuracy, but it is not for good fairness prediction. It also incorporates demographic parity, fairness constraints in my paper. My DP fair hybrid MTL achieves 94.8% gender accuracy, F1 score of 0.946 and MAE of 3.21 years, age prediction, and my EQHN hybrid net delivers the best performance of 95.6% gender accuracy. Here EQHN hybrid net are basically for accuracy purpose and DP fair hybrid MTL for fairness purpose. So next please. The introduction of my research work is, I am going to predict age and gender both with the facial images using multitask learning model rather than single task model. It is combining both the features from facial expressions and predicting the age and gender accurately with the fairness. Existing model only focuses rather on age prediction or gender prediction, but my model predicts both with the fairness accuracy. So please next. These are the literature review for my research work. I have reviewed these papers and find the limitation on this, that there is a computational complexity is very high and they are lagged in fairness. Next. These are some papers. Next. My research gaps, and I have found some research gaps in this, that the limited research is focused on simultaneous age and gender prediction using unified multitask learning framework. Existing models prioritize prediction accuracy over fairness, which is not good for some sectors like security and healthcare focuses on fairness also. That's why I have to focus on fairness. I have integrated demographic parity constraint for age and gender prediction. Many fairness approaches experience significant fairness accuracy ratio trade-off, reducing overall model efficiency. Current solution frequencies suffer from high computational complexity and scalability issue. So I have also overcome these. There is a lack of, there are some models which lacks hybrid CNN attention models. So in my model, I have combined both CNN plus attention mechanisms for weakness. These are the objective of my research work. The first objective is to develop a fairness-driven multitask learning framework for simultaneous age and gender prediction from facial images. Second, I have integrated demographic parity constraint in my research work. The third is I have also designed hybrid CNN attention architecture so that I can overcome the drawbacks from the previous models which lacking in fairness. Please next. So these are the methodologies. Data collection, I have collected my data from Kaggle. After that, I have pre-processed my data, resized it according to my research. After that, I have hybrid feature learning backbone. This is the most important step because here I have combined CNN with the attention mechanism. After that, I have put my data on DP hybrid MTL and EQHN hybrid net models, so they can extract age and gender of from facial images. After that, I have trained my data from all these and get the result. Next. These are the methodology point overviews that I have also put integrated demographic parity constraint and fairness aware learning in it. Next. These are the results of my research work. EQHN hybrid net achieved the best performance overall with 95.6% gender accuracy and 0.952 F1 score and 3.05 year MAE. DP hybrid MTL achieved the highest fairness, significantly reducing demographic bias, which is the challenge here. Both proposed model outperformed baseline CNN and standard MTL model in age and gender prediction. As I discussed, Further, the hybrid CNN attention architecture are also utilized here with demographic fairness and prediction accuracy as in my mind. These are the results. Baseline CNN gender accuracy is 89.6, age MAE is 4.35, gender F1 score is 0.887, standard MTL has gender accuracy of 92.4, MAE of 3.78, gender F1 score is 0.9818. My both model DP Fair hybrid MTL exceed these. DP hybrid MTL actually I use here for fairness purpose, and EQ agent hybrid net I use for accuracy as well as fairness purpose. Next. These are the graphs for result and so next. The conclusion of my research work is I have developed two hybrid multitask learning model, DP Fair hybrid MTL and EQ agent hybrid net for agent gender prediction using facial images. I have integrated hybrid CNN and attention architecture to improve feature extraction from facial images. After that, I have incorporated fairness aware learning techniques to reduce biasness among the demographic groups with maintaining high prediction accuracy. These two models exceed the previous baseline model and single MTL model. DP Fair Hybrid achieve lowest demographic parity difference and EQHN focus on achieving high prediction accuracy. Both models outperform traditional models and share representation, learning, fairness, optimization significantly, improve the effectiveness of age and gender prediction. Future work can focus on developing lighter and more computational efficient models suitable for deployment in the resource constrained environments. So next.
Only 2 minutes and
एज एंड जेंडर कुछ ठीक हो गया ना
जी
तो आपका प्रोग्राम क्या कर रहा है
एज एंड जेंडर प्रिडिक्ट कर रहा है सर
awareness aware multitask learning for age gender प्रोग्राम पैरिटी कंस्ट्रेंट्स क्या होता है डेमोग्राफिक पैरिटी कंस्ट्रेंट्स
सिर्फ डेमोग्राफिक पैरिटी कंस्ट्रेंट्स हमने कुछ कंस्ट्रेंट डाले हैं यानी कि कुछ फीचर्स हमने बताए हैं कि इन्हीं पे उसको वर्क करना है जैसे कि जैसे CNN और अटेंशन मैकेनिज्म सब मैंने यूज किया CNN ओनली बेसिक फीचर्स को ही एक्सट्रैक्ट करेगा बट अटेंशन मैकेनिज्म दोनों में जो एज और जेंडर को बताने के लिए जो कॉमन फीचर रहेंगे उनको निकाल के रिस्पेक्टिवली बताएगा कि इनको रिप्रेजेंट करके आप और अच्छे से उसकी एक्यूरेसी और फेयरनेस बढ़ा सकते हैं
साधारणतया देखें तो आप क्या क्या फीचर्स देखते हैं एज और जेंडर
सर एज और जेंडर अगर मैं फेशियल फीचर्स में बताऊं तो हम रिंकल्स वगैरह चेक करते हैं और अगर मेल्स में बात करें तो बियर्ड और हेयर लाइंस ये सब चेक करते हैं
तो आपके सॉफ्टवेयर में क्या क्या पैरामीटर्स लिए उसने चेक किए
सर उसने पैरामीटर्स लिए हैं बेसिकली उसने फॉरवर्ड के पैरामीटर्स ज्यादातर लिए हैं यानी
आपने इसको ट्रेन भी किया हुआ
सर अभी ट्रेनिंग ऑनगोइंग भी है कुछ चीजों पे वो ट्रेन कर चुके हैं हम जैसे कि मैंने आपको बताया 4.8 पे हमने देखा है उसके बियर्ड पोर्शन देखा है और चीक्स पोर्शन पे अभी चेकिंग की थी
मगर अलग-अलग जगहों पर अलग-अलग चेहरे होते हैं
हाँ
उससे एज प्रेडिक्शन करने में दिक्कत आती है
जी सर
उससे कुछ
तो उसी के लिए मैंने अटेंशन मैकेनिज्म
ये मुझे लगता है ऐसा होता है
सर
हम अपने यूपी के लोग देखते हैं एमपी के लोग देखते हैं नॉर्थ ईस्ट साइड चले जाए तो चेहरा हो जाता है
जी
उससे एज प्रेडिक्शन करते हैं यहाँ तो पता कर लेते हैं एक साल 30 साल आसपास है अप्रोक्सीमेटली वहाँ पर दिक्कत आती है वहाँ इंग्लिश में जल्दी बढ़ जाती है देखता हूँ
सर की एज प्रेडिक्ट करो
सर मैं मॉडल
ट्रेनिंग चल रही है उसकी ट्रेनिंग
हाँ सर इट्स अंडर
वैलिडेशन
यस सर
तो इमेज तुम क्या डेटा ले लो कि इमेज ले रही हो
सर मैं जो डेटा लिया है वो कैंडल से हमने फेशियल इमेज का डेटा सेट लिया है
नहीं डेटा मैंने डेटा लिया है कि वहां से इमेजेस के फॉर्म में डेटा लिया है कि टेक्स्ट के फॉर्म में
सर हमने डेमोग्राफिक उसमें काफी सारे डेटा लिए हैं हमने फेस का डेटा तो लिया है बाकी सारे पैरामीटर्स भी हमने लिए हैं फिर उससे एक्सट्रैक्ट किया है फेस के कुछ फीचर्स को जो हम स्पेसिफिकली आगे बताना चाहते हैं
एक फीचर बहुत गड़बड़ हो सकता है आपका एआई लगाओ फिल्टर देखो
कौन सा
अब किसी बाल ना हो सब बाल वाले किसी भी बाल हो सकता है 22-23 साल में आजकल हेलमेट लगाते बाल वाले तो बाल जिसके नहीं होते वो लगता है वो होने लगता है 25 साल में तो आपको ये इस एआई को इसको कैसे आप फिल्टर करोगे इस चीज को भाई वो भी लेगा फिर फोरहेड पे मेरी बाल बहुत कम हो रही
तो सर हम सिर्फ अगर आप बाल की बात कर रहे हैं तो हम सिर्फ बालों पे ही नहीं फोकस करेंगे ना सर, वी विल स्किन टेक्सचर आल्सो बी मेजर ना सर, स्किन टेक्सचर तो बता देगा ना कि नो इट इज 10 साल का थोड़ी ना है ऐसा
स्किन का ही देगा
बिल्कुल
किसी
आई विल
25 एआई से 25 साल के आदमी के बाल लगाना देखो कितना सॉफ्टवेयर काम करता है
आई विल ट्राई
करने जब रिजल्ट्स देखने पड़ते हैं ऐसे
हाँ ओके थैंक यू सर
तो कहाँ यूज आएगा सही तो बताओ
क्या सर
ये जो तुम एमटेक कर रहे हो पूछा है तुम एमटेक ना
यस सर
कहाँ यूज हो सकता है इस चीज को बनाने वाला
सर हम इसको सिक्योरिटी के पर्पस पे यूज कर सकते हैं, हेल्थ केयर सेक्शन में यूज कर सकते हैं सर, जैसा आपने अभी बताया मुझे कि अभी हम देख सकते पोस्टमार्टम में यूज हो सकता है सर। कल को आप बोलेंगे ना कि कैसे जो चले गए हैं अभी उनकी एज क्या है ये सब करके
वो लगा मार्कशीट डबल की लिखी है आपका सॉफ्टवेयर मांगे मार्कशीट मांगे
सर
मार्कशीट पूछा
आई एम गिविंग जस्ट सम एप्लीकेशन सर कि वो वहां पे भी यूज हो
अगर
सकता
कहीं जाएंगे पासवर्ड कर लेंगे वो डेट ऑफ बर्थ मानेगा 10 वाले
हां सर
तुम्हारा सॉफ्टवेयर किट मानेगा कि सॉफ्टवेयर बोलते हैं
सर मैं ट्राई करूंगी कि मेरे सॉफ्टवेयर की माने थैंक यू सर
Thank you so much. Now I would like to call Ankita Malviya ma'am to present AI-powered drone detection using convolutional neural network for enhanced border surveillance. Please put your hands together.
Good afternoon, sir. Thank you, please. My name is Ankita Malviya, pursuing MTech from BIST Bhopal, and I am presenting here my research on AI-powered drone detection using convolution neural network enhanced border surveillance. Next slide. Here are the outlines of my research: abstract introduction, literature review, research gap, and objective, where I have explained in the next slide. Next. There is aerial vehicle uses as created for security, but it has some limitations, and conventional border protection has some limitation in observe the model and network extract special details from hierarchical layers. Models achieve overall classification 94% accuracy and crucially non-detection classes 0.99. Here are the drones are widely used for threatened border misuse, and unauthorized drones are used for border surveillance and smuggling. Border regions are large, complex to recognize their security manually. And there are the data analysis. I have data set given to the drone which I have taken from the cable, and here are the deep learning CNN model is used in my model. Next. There are the literature review where there is my base paper. YOLO based one is multi-sensor and UAV detection and data set detection. Next. There is a pure generalization of model in real time. That is, we can't recognize small objects like birds and flies. So that we are trained the model with more large data sets and 10,000 more images, so that we can recognize the object like drone. Next slide. The main objective is that we have get more best result regarding with accuracy, regarding with minimal false alarm, and regarding with stable validation. Next. There is my proposed methodology where I have given data to image and pre-processing through CNN structural model, and then we have classified images such as data set, birds, flies, etc. And when we get the result. Here are the results and discussion of my models. We are here achieving 94% accuracy with the consistent result and stable conversion. Next. Next.
My future work is that model achieve 90%, 94% accuracy with the highly efficient model trained by CNN neural network, and that will be used for national security using AI. Next. These are my references. Next. Thank you.
Limitations क्या आपके वर्क में लिमिटेशन ऑफ योर वर्क
सर लिमिटेशन जैसे ऑब्जेक्ट्स होते हैं, स्मॉल ऑब्जेक्ट्स कई बार रिकॉग्नाइज नहीं कर पाते हैं। इजीली विद योलो जो यूज हुआ था रिसर्च गैप में, उसमें यही लिमिटेशन थी कि हम इजीली रिकॉग्नाइज कर पा रहे थे। तो इसमें अपन ने और डेटा सेट डाले हुए हैं 10,000 अराउंड, वी हैव गिवन डेटा सेट इन दैट so that we can recognize easily even small objects like bird, flies, etc.
implement कैसे करें?
Yes.
Implementation कैसे करें?
Sir, Python.
So data collect
Sir, Kegel से ले. Yes.
सॉफ्टवेयर सिमुलेशन बेस्ड है सर। ठीक है।
Okay. Thank you.
Thank you to all presenters. Please put your hands together for them. We have reached the final segment of the